Welcome to session 3 of our course. We have some really interesting material to discuss this week on the topic of organizational sociology and the work of Diane Vaughan. Diane Vaughan, whose book you've read for today, is another important founder and contributor to the organizational sociology of large accidents. Like Perot, she is interested in uncovering the organizational dysfunctions which contribute to the causation of accidents, the large failures which we've named as examples, like Bhopal, Chernobyl, Boeing 737 MAX, and of course the Challenger disaster of 1986. Her background proceeds through meticulous study of the occurrence, the background of the occurrence and the unfolding of the accident. And she works almost as an ethnographer, working with contemporary documents, interviews with participants, review and even participation in commissions of inquiry, emails which proceeded among the various participants and experts and managers and engineers, and other materials which allow her to reconstruct the decision-making process as the lead-in to the accident occurred, but more importantly, as the process of designing the device, designing the system, and arriving at assessments of which technology should be chosen and what levels of risk are acceptable. And her major contribution is something new. I believe this is really original and novel with Diane Vaughan, a new hypothesis about organizational failure. It is her idea of the normalization of deviance within an organization. And I'll be explaining in the next several slides what she means by that. But the specific case which she studies from beginning to end is the Challenger launch disaster of 1986. And as I think probably you all now know quite well by having read the book, the Challenger exploded shortly after launch in January of 1986 from the launch pad in Florida. Subsequent investigation showed that the immediate cause of the explosion was substantial leakage from an O-ring, which is a flexible material which seals the joint between two rigid pieces of metal. There was substantial leakage, or what they refer to as blow-by, in an O-ring on one of the shuttle's main engines, fatally damaging the craft and leading to an explosion of the rocket fuel, which in a few seconds destroyed the vehicle. Further investigation showed that indeed there had been a long history of O-ring damage in previous flights, and an indication, forensic indication, engineering indication, that O-rings had been damaged by the heat of ignition, and that a degree of penetration of the ring had occurred in previous flights as well. The Rogers Commission eventually learned that there had been explicit warnings from the engineering team of the rocket contractor, Morton-Thiokol, against launching under the expected cold conditions in Florida only 24 hours to 36 hours before the launch. So what is the context, the organizational context? NASA is a government organization, and Morton-Thiokol is a corporation which contracted with NASA to build the solid rocket system. NASA was under a huge amount of production pressure because of its recent history of funding and the legislative and congressional both support and pressure on NASA to deliver a very aggressive launch schedule of 24 launches with the 5 vehicles per year in order to make the program economically viable. Each payload would have some commercial material, which then private corporations would be charged for. And the idea was that with 24 launches per year, the revenue coming from those private payloads would be sufficient to offset the cost of the program. So there was a lot of congressional pressure to maintain launch schedule, which NASA was not meeting. Furthermore, there was a kind of a curious moment. President Reagan was about to offer his State of the Union address, and Krista McAuliffe, the teacher who was scheduled to be one of the astronauts, was to be featured in his State of the Union address, and a delay of the launch would interfere with that possibility as well. Now let's turn to Morton-Thiokol. It was a corporation, and as in the particular business circumstances that it was highly dependent on its contracts for rocket motors with NASA. It needed to demonstrate that it could deliver, and it needed to compete against other companies after a threatened lapse of the sole source purchasing contracts by NASA. So both NASA as a public agency, a large organization, and Morton-Thiokol, a specialized corporation, both under serious production pressure to deliver launches as close to on schedule as possible. So the initial theory that one might put forward, and we might be inspired to put forward by both newspaper coverage, but also by normal accident theory, is the idea that organizational misconduct led to the accident, the crash, the disaster. And indeed, Diane Vaughan indicates that that was her initial hypothesis as well, that the production pressure on managers, the willingness to take risks that harmed safety in order to achieve organizational goals, and eventually regulatory failure as well. These organizational dysfunctions and forms of misconduct, she considered at the beginning of her research that these were the causes or were important background causes of the failure. But what really surprises you as the reader is that in the end she comes to the conclusion this isn't exactly what happened in the Challenger disaster. In fact, she finds that rules were not violated, that the decisions which led to the launch in January 1986, the rule system concerning launch had been almost entirely observed. The O-ring damage which had occurred in past flights had been evaluated according to normal process and had been determined to represent acceptable risk. And in the end, she came to believe that what this reflected was something which she now refers to with a new term, normalization of deviance. And so she kind of describes her own internal scientific revision of hypothesis in these terms. This book contradicts conventional interpretations of the Challenger launch decision. It presents both a revisionist history and a sociological explanation. And that's in the preface to the original volume. The preface 20 years later is also very, very interesting and important for us. So the critical issue in a technology organization like NASA or a high-tech company like Morton-Thiokol is the issue of risk evaluation. This is a problem of scientific and engineering expertise. What is an acceptable risk and what is an unacceptable risk? And in the development of new complex technologies, this is all the more difficult because there's a much wider range of uncertainty about what the consequences of one form of malfunction or another might be. And it turns out her very careful kind of ethnographically informed study of the processes which led from the very inception of the solid rocket propulsion system before the space shuttle program, all the way up to launch, what she came to discover is that the process of risk evaluation is not a simple scientific or engineering decision. Rather, it is the result of a complex process of negotiation, debate, and mutual adjustment. And Vaughan puts, in her study of organizations, she puts a great deal of attention on the norms and culture of the organization as determinants of behavior within the organization. Here's what she means by norms: cultural beliefs and conventions originating in the environment which create unreflective, routine, taken for granted scripts that become part of the individual worldview. So let's now move into January 1986. A surprising and very rare cold front was expected in Florida, with temperatures expected to be in the freezing range, 32 degrees. A special launch conference was convened, teleconference, to evaluate the safety of the launch under the expected low temperature weather conditions in Florida. in particular, engineers from the solid rocket motor division of Morton-Thiokol, the engineers who had worked on both the design of the rocket, the implementation of the rocket, and also evaluation of the evidence of seal leakage in previous fires, previous launches. This team was asked to review the safety effects of possible cold temperatures. And it was well understood that cold influences the material properties of the seal. It makes it more, less resilient. And therefore, this is the really important point, less able to, in milliseconds, expand under the impact of hot gases to fill the gap between the two rigid segments of the motor. The engineering team from Morton-Thiokol came to an evidence-based recommendation, and this is quoting from Vaughan. The Thiokol engineers expressed concern that the cold would affect O-ring resiliency. The rings would harden to such an extent that they would not be able to seal the joints against the hot gases created at ignition, increasing the amount of erosion and threatening mission safety. They, in the end, recommended a launch temperature threshold of 53 degrees Fahrenheit, whereas the predicted ambient temperature in Florida was about 32 degrees. So this was the formal recommendation of the engineering team from Morton-Thiokol. The NASA administration, the senior administrators responsible for the upcoming launch, were astounded and flabbergasted at this recommendation. Larry Malloy, who is a central figure, he was the senior NASA launch administrator, recognized immediately this means havoc for the launch schedule. My God, Thiokol, what do you want me to do? Launch next April. This then led to an offline caucus of the engineering and Morton-Thiokol corporate leadership. And a senior executive from Thiokol, not from the engineering division, after hearing strenuous conversation between the engineering team, which did not retreat from its recommendations about unacceptable risk of launch under the cold conditions, the senior executive from Thiokol is quoted as saying, "We have to make a management decision." The engineers continued to object strenuously, including two who subsequently became pretty well known for their honest statements about what transpired, Arnie Thompson and Roger Beaujolais, who continued to offer data to support the loss of resilience problem. But management made a decision to recommend launch at the predicted temperatures. Allan McDonald is another of the engineers. He was a supervisory engineer, administrator or manager at Morton-Thiokol, and his book, which you've read just a few pages of, Truth, Lies, and O-Rings, he too became a very energetic and angry whistleblower. He advocated for the engineering group at the time of the caucus and the launch conference. He advocated for the recommendation coming from the engineering group against launching below 53 degrees Fahrenheit. And in the snippet that you've read, he goes into a great deal of detail about the special launch conference and puts forward substantial documentation and technical evidence-based doubts of O-ring integrity, which had been constructed by the Morton-Thiokol engineering team. What is interesting about this is that the assessment of risk and safety that was put forward by the engineering team was not the basis of, was not put forward on the basis of intuition or I've got a bad feeling about this launch. Rather, it was a sober engineering assessment based on the data of previous launches. Here's a quote from McDonald. I won't read the quote, but his interpretation is precisely the hypothesis which Diane Vaughan rejects early on, namely bad behavior, improper behavior by both NASA and Morton-Thiokol corporate leadership under production pressure, which was related to really important commercial and governmental interests of the two organizations. So what is Vaughan's interpretation? What is the idea of normalization of deviance? She believes that the McDonald hypothesis that goes straight from the interests of the company or of NASA through a kind of amoral rationality, which pays no attention to the harm which may be created by risks which turn out to be real catastrophic consequences, to disaster, that this theory is too simple and in large it is misleading. Rather, she believes that a more insidious social process was at work both in NASA and also in Morton-Thiokol, which she refers to as ethnocognition. This is not a term I'd ever encountered before reading Vaughan. And another term which was novel in her work called normalization of deviance. And what she is basically describing is a very dynamic process of knowledge gathering, perception, calibration by working groups of technical experts who react to each other and to the evolving experimental evidence to gradually reduce their requirements on what safe launch and flight requires. And incidentally, we might consider whether the Boeing 737 MAX design process in the history, which is now reasonably well known, whether that process would also be understood as a kind of normalization of deviance in the redesign of the MCAS system, the anti-stall autopilot system. So here are a couple of quotes that I do think are worth highlighting. The premise of this book is that individual behavior cannot be understood fully without taking into account the organizational and environmental context of that behavior, and therefore it's necessary to pay attention to the norms and culture of the organization. And what she finds at NASA and the engineering groups is that each time evidence initially interpreted as a deviation from expected performance was reinterpreted as within the bounds of acceptable risk. That sentence really captures the idea of normalization of deviance. If 0.003 millimeters of tolerance was expected and stated as a standard for the O-rings, and in a particular flight 0.005 is recognized, is measured, and then it turns out that it was a safe test. The 0.005 deviation of the O-rings did not lead to catastrophic failure. Then the rule is rewritten and 0.005 becomes the standard rather than 0.003. That would be in a capsule what she's referring to as normalization of deviance. So it is a mistake based on conformity to cultural beliefs, organizational rules and norms, and NASA's bureaucratic, political, and technical culture. These quotes I think are useful for you to read, but I won't read them. But her basic view is that the pressures and the organizational causes mentioned above, her view is not inconsistent with Perot's view, or for that matter with Andrew Hopkins' view. They both kind of advocate that fairly direct causal connection between organizational interests, production pressures, cost cutting, and catastrophe. Vaughan's view is not inconsistent with that sequence. Her view is not that the pressures and organizational causes are not a part of the story, but rather that there is an unidentified and chronic problem as well, the normalization of deviance, which results from highly expert, highly committed, technically highly competent teams adjusting and kind of working through their technical decisions about safety and about the performance of the technology which they are both constructing and overseeing. Here's a good example that she offers: a 5-step decision-making sequence in which the technical deviation of the solid rocket booster SRB joint from performance predictions was redefined as an acceptable risk in official decisions. This is what she found: a formal decision-making sequence in which the technical deviation of the joint from performance predictions was redefined as an acceptable risk. Engineers and managers, again quoting from her, engineers and managers together developed a definition of the situation that allowed them to carry on as if nothing was wrong when they continually faced evidence that something was wrong. And what she describes is really a process which is kind of chilling, because we see these, brilliant, highly qualified engineers and managers moving down further and further in the direction of a specification of standards which is almost guaranteed in the end to give rise to a catastrophic failure, and yet they don't notice this process. They don't stop the process, they don't reverse the process. What she is engaged in is what she calls ethnocognition, or the study of ethnocognition. A useful quote: "To trace micro-level decision-making as we have done is to study ethnocognition, the way that members of a particular group produce a definitive mental model as they construct, negotiate, and assemble knowledge to give meaning to an object," the O-ring in this case. "But cultural influences from the environment affect local situations." Now, the tragedy which Diane Vaughan highlights in the new preface to the book is the fact that these same processes of risk adjustment, downgrading of the official assessment of the riskiness of an observed behavior, those same organizational flaws which existed in NASA leading up to the 1986 disaster, the same flaws can be identified in the Columbia Space Shuttle disaster of 2003. The Columbia disaster had a different technical causation. The launch went forward. Video monitoring noted that a chunk of foam debris had broken off during launch, had struck the vehicle. There was, at that time, as the launch was proceeding and then as the vehicle got into orbit, there was concern that the strike might have damaged the protective heat tiles of the vehicle, which are absolutely crucial to safe reentry. The heat tiles protect the vehicle from the extremely high temperatures of atmospheric reentry. Observation by low-resolution cameras was available, but the incident was dismissed as a serious risk to safe reentry. And why was it dismissed? It was dismissed because many previous flights had also had chunks of foam fall off, had minor damage to the vehicle, heat tiles, which had to be replaced, and this had been normalized as an acceptable risk. This is another incident of normalization of deviance. And another piece of the story is also parallel to the Challenger story, and that is the fact that a team was specifically convened to assess whether there was a serious safety hazard created by the strike of the debris. And that team recommended that it was necessary to have better imagery to know what damage might have occurred to the heat tiles or to the heat insulation. And they requested redeployment of a military satellite to take high-definition photographs of the vehicle while in flight. This was turned down by a senior NASA administrator on the grounds that it was not coming from the right pathway, not coming through the right channels. It's hauntingly similar to the fact that in the Challenger disaster, we have the Morton-Thiokol team saying don't launch. In the Columbia disaster, we have a team saying before we proceed with a landing or a re-entry 7 or 8 days later, we need to inspect the tiles, and that recommendation was declined. So is Diane Vaughan offering a competing theory to normal accident theory? She is certainly offering an organizational theory. She is an organizational sociologist. She is ethnographic in her approach, using the transcripts, the interviews, the meeting documents, which you've now read in a fair amount of detail. But what she tries to contextualize is that the partially correct theory of what went wrong is only partially correct. That the points about production pressure, business rationality, undervaluing safety, organizations pursuing interests rather than public, or worker safety, those considerations are present. But in addition to that, there is this other important and kind of chronic situation of an organization readjusting its assessment of risk through the pervasive interactions which occur within the organization, mediated by the organization's culture. And her alternative theory, her additional theory, is that the workings of routine mental representations of risk within a moving organization lead to the normalization of deviance. And what I would say is that these are complementary theories. The mechanism which Diane Vaughan is referring to doesn't replace the idea that cost cutting or production pressure or maintaining the launch schedule, that these are important causes of organizational behavior. She is adding an additional factor, which is that on top of that, the organization has now convinced itself that the action which it is undertaking out of concern for profitability, maintain the launch schedule, keep Congress happy, that those actions are within the appropriate range of acceptable risk. She does conclude the book with a bit of optimism, and I'll read this quote. "Change that connects strategies of control to the organizational causes of some harmful outcome can reduce the probability that it will recur, but we can never prevent a repeat because of the recalcitrance of systemic causal factors. Nonetheless, reducing the probability of a recurrence is an important goal." And I would just point out that this is a kind of foundation of the orientation of the idea of a high reliability organization, which we'll be studying in the next couple of weeks. These are efforts to connect strategies of control to the organizational causes of harmful outcomes. So I look forward to talking about all of these materials on Monday.